Hello everyone, can you hear me?
Hello，老师。
你好，老师。
Okay, good morning.
Finally, 老师, I can connect.
Okay,
Good morning,
first we will solve the homework last week. And how do you think the homework, are the exercises difficult or not? How do you feel? Guys, how do you feel the homework? Can you work out all the homework, all the exercises?
Yes.
Yes.
Yes, 老师.
Wow. So first we will solve the first homework. And here, the first one. Okay, the first homework that is very similar to the last question last week, right? So the first that is to calculate the integrand here, that is 1 by x times 1 plus x power 8 dx here, right? And last week we have talked about this kind of indefinite integral, how to solve this kind of indefinite integral. So here I will choose one of the two methods, right? And you can choose each one that you are very familiar to. So here, as I noticed that here that the power is 8. So I want to separate the integrand. So here the power should be 8 too. So the first step one, we have to treat the integrand first. So 1 by x times 1 plus x power 8. That equals to, here, if I want the denominator, that is x power 8 times 1 plus x power 8, then to be these two equivalent, then here numerator should be x power 7. That is because x power 7 and x power 8, then we can cancel x power 8, then get the things we want, right? So here, this is the first step. And then we know that equals to here. That equals to, here first, we cannot consider x power 7, or you can put x power 7 outside the function. So that is x power 8 times 1 plus x power 8. Then times x power 7, right? And then we know here we can suppose that u or t equals to x power 7, right? So this part that is u, and this part that is 1 plus u, right? And here, don't forget, we have to know that dx and du, the relationship between dx and du. So here we have to know du, that equals to dx power 8. And that equals to x power 8 prime dx, right? And x power 8 equals to 8x power 7 dx. So here we know that x power 7 appeared, right? So we know that the integral that should be here, that equals to 1 by this part here, that is u. And this part, that is 1 plus u. So u times 1 plus u means x power 8 times 1 plus x power 8, right? And then we know here we have x power 7 here, right? So here, you know, that is here dx, here dx, right? So we have to know x power 7 times dx. And here we know that x power 7 dx should be 1 by 8 du, right? So here we know that is times 1 by 8 du. And then we can take the constant 1 by 8 outside the integral sign. So that equals to 1 by 8, 1 by u times 1 plus u du here. So for this step, any questions here? Any questions here? No? Okay. So any questions? No? So here, first we use the substitution rule, but we should notice, we should figure out how to suppose, right? So here, the best way to solve this question, that is to let u be x power 8, or you can let u be 1 plus x power 8. That is also okay. So we have changed the original integral to this kind of type. So here we have to solve this equivalent integral here. And we have to separate the integrand here. And we should know that 1 by u times 1 plus u, that can be separated to two parts. And the first part, that is 1 by u. And the second part, that should be 1 by 1 plus u, right? So here we want to know plus or minus sign here between these two functions. And I want to know if they are equivalent. So here is a way we usually use to separate the function like this. That is, we can suppose the first, that is a by u, and plus b by 1 plus u here. And then we know that a by u plus b by 1 plus u should be equal to u times 1 plus u, right? And here the first should be a times 1 plus u. And the second should be b times u, right? And we put all the u together. So that is u times 1 plus u. And here first, that is a plus au, right? So that is a plus b u. And then plus a. And then plus a here. So for this part, you can see that if we want these two parts here and here, if we want these two parts equivalent, that should be, the numerator should be 1, right? So here that means a plus b should be 0, because here that is a constant 1 without u, right? So a plus b should be 0 and a should be 1, right? So we know that a should be 1 and b should be minus 1 here, right? So we know that 1 by u times 1 plus u can be written as 1 by u plus, here b means minus 1 here, right? Minus 1 by 1 plus u. So that is 1 by u minus 1 by 1 plus u. So guys, can you understand this part? Can you understand? Do you have any questions here?
Laushik, can you repeat again, please?
Okay. So here, the integral that is 1 by u times 1 plus u, right? But we don't have a formula we can use directly to solve it. So here, we want to separate this integral. Separate to two parts, because if we can separate it, that this part we have a formula, and this part we have another formula. So we can also use the formula. So if we can separate it to two parts, that will be easier to calculate the integral. So here is how I separate it. So we know at the denominator here, that is u times 1 plus u, right? So we can separate it to two parts, that is a by u plus b by 1 plus u here. And now I want to know u equals to what and b equals to what here, right? So here we know that a by u plus b by 1 plus u, that can be written as here, this part here. This part here, you know that 1 plus u can be cancelled. So that is a by u here, right? And the second part here, u can be cancelled, right? So that is b by 1 plus u here. So we know that we can product one by one. That is a here. Here I will write another step here. U times 1 plus u here. That is a plus a times u plus b times u here, right? And now we know that is a plus b times u plus a. And here, numerator here, that is 1. That means a plus u should be 0, because 0 times u equals 0, right? And a should be 1. So we have a equals 1, and of course b equals to minus a, right? So minus 1 here. So we have that the integral can be written as 1 by u minus 1 by 1 plus u here. So here we have changed the integral to 1 by 8. Here that is 1 by u minus 1 by 1 plus u du here, right? And now we can change it, separate it to two parts, use the sum rule here. So that is 1 by 8 times the first, that is 1 by u du, right? And second, that is 1 by 1 plus u du, right? And here we can calculate one by one. The first, I will give it a mark, that is 1. 1 equals to ln u, absolute value of u, plus c, right? Because we have a formula, we can solve it directly. And for the second one, that is 1 by 1 plus u du, and here you can let t equals 1 plus u here. And then we know dt equals du, right? So that can be changed to 1 by t dt. So that equals to ln absolute value t, right? And t equals 1 plus u. So that is ln 1 plus u plus c here. So we can put these two results back here. So the integral I equals to 1 by 8. Don't forget it. And then times the first should be ln absolute value of u, right? And minus ln 1 plus u here, right? And plus c. Here, you may see here plus c, right? But they cannot be cancelled here because the constant c here and the constant c here means arbitrary constant, but they cannot, maybe they are not the same. So if you want to make it clear, you can write C1 here and C sub 2 here. So you should know that they are not always the same here. So we have I equals 1 by 8 times ln absolute value u minus ln absolute value of 1 plus u here. And here we have a property for the function ln here, that is ln A minus ln B equals ln A by B. Yes, we have a property here, and another property that is ln x power n equals n times ln x. And these two are the properties for ln x, only ln x, okay? Not every log x, a log function. So here is minus, right? So we can put these two parts together. So that is 1 by 8 ln absolute value u minus 1 plus u here. U minus 1 plus u here, and then plus c. And you don't have to write this step if you have calculated correctly to here, and then you substitute u equals x power 8 back. That is also okay. That is also right. So I have told Omar he doesn't have to use the final property here. That is also okay. I just want you guys to know the properties for function ln and see the result more clearly here. So I put them together, use the property for ln here, and that equals to 1 by 8 ln here, that is x power 8 by 1 plus x power 8, and then plus c here. So it is the final result for this question for the first homework. Okay, any questions? Do you have any questions here?
No, Loshi.
Okay, good. Okay, good. And then we will solve the second one. And the second one, I think that is easy, right? The second one, that is, we want to calculate the indefinite integral x by 1 minus x dx here. And here, the integral that is x by 1 minus x. And so here, we also want to separate it to two parts. So here, x by 1 minus x. That can be written as here. We notice that the denominator that is 1 minus x, right? So here, we can write x minus 1. And then don't forget to plus 1 here, because they should be equivalent here. So 1 should be removed. And then we can separate it to two parts. The first part, that is x minus 1 by 1 minus x, right? And the second part, that is 1 by 1 minus x, right? So we know that equals to minus 1, and then plus 1 by 1 minus x. And to simplify the calculation, we can write it as here. You can write minus here. That is minus 1 minus 1 by x minus 1, right? So here, the original integral can be written as minus 1 minus 1 by x minus 1 dx. And here we can separate it to two parts. The first, that is minus 1 dx, right? And the second, that is 1 by x minus 1 dx here. So the first part, I think you know that equals to minus x, right? And the second part, this part, here, you can use two ways to solve it. The first, here, you can let t equals x minus 1, right? So dt equals dx. Here we know that equals 1 by x minus 1 dx equals to 1 by t dt. So that equals to ln absolute value of t. Don't forget to plus c here. Don't forget it. So that equals to ln x minus 1 plus c here. This is the first way. And here is another way that you can solve it directly if you are very familiar with the formula, with the substitution rule here. You should know that equals to 1 by x minus 1 d x minus 1, right? Because dx minus 1 equals dx. So here, these two parts are the same. X minus 1, x minus 1, right? So we can use the formula directly. That is minus x minus ln absolute value of x minus 1. And then the last part, that is plus c here. So here is the second question. So do you have any questions here? Can you understand? Can you follow me?
Laushi, if I didn't minus sign here, we don't solve it?
Here, if you don't write minus here, then should be this step, right?
Yes, Laushi.
Yeah, and here, if you want to use the substitution rule, you should pay attention to the sign. That is here. Okay, I will write below that if I didn't change it.
Yes, Laushi.
Okay, that equals here should be minus 1 and then plus 1 by here, that is 1 minus x. Right? And
Yes,
the first part that are the same, minus 1 dx. And the second part, that is 1 by 1 minus x dx here. And this part also equals to minus x. And this part, you should pay attention to that you can let t, here I will change the letter u here, equals to 1 minus x, right? So you will find that du equals to d 1 minus x, and that equals 1 minus x prime dx. And that equals here 1 minus x prime equals minus 1, right? And times dx should be minus dx here. du equals minus dx here. So 1 by 1 minus x dx equals to 1 by u, and times dx should be minus du here. So you have a minus sign here, that is 1 by u du. And that is also equals minus ln absolute value of u plus c, right?
It's same, Logi, right?
Yeah, they are the same. Yeah, they are the same. But there is a little bit difference between the procedure, right?
Yes,
So
Logi.
here,
But Logi, I use here 1 minus x d bracket 1 minus x, so that I directly use this the ln 1 minus x plus c here.
yeah.
If I get 1 minus x here, so that I directly use ln 1 minus x here.
If you use 1 minus x, here should be 1 minus x, but the sign should be changed.
Logi.
Okay, so that should be ln minus ln. Yeah, that is here. That is x. Sorry, ln plus c, because you know that the absolute value of x minus 1 equals the value of 1 minus x, right?
Okay, Logi.
Here should be the minus sign here. Don't forget it.
Logi.
Okay. So here is the second question. Any other questions? Other doubt? Okay, now we will go to the third one. Okay, please remove the right circle. And the third one, the question that is to calculate sine x squared dx. And if we want to solve this indefinite integral, I think you should know one formula for a trig function. So here, I think you should know that sine x squared plus cosine x squared equals 1. I think you know it. But there are two formulas we often use for trig function. The first, that is sine 2x. Sine 2x does not equal to 2 sine x. Here, you should know it. 8 equals to, here, sine 2x equals to 2 times sine x times cosine x. 2 times sine x times cosine x, that is sine 2x. And here is another, that is cosine 2x. And cosine 2x, that equals to 2 times cosine x squared minus 1, or equals to 1 minus 2 sine x squared. So I think you should know these three formulas, then you can solve this question. Because here we have seen sine x squared, right? So we want to change it by cosine x. We don't want the power 2 here because the formulas we have learned that every formula doesn't conclude square, conclude power 2 here, right? So we want to remove the power. So we use this formula. So we know that cosine 2x equals 1 minus 2 sine x squared, right? So we know that 2 sine x squared equals to 1 minus cosine 2x, right? So sine x squared equals to 1 minus cosine 2x by 2, right? So the first step, we have to rewrite the integrand by the formulas here. So the first, that equals to 1 minus cosine 2x by 2 dx. And 1 by 2, the constant 1 by 2 can be taken out. So that equals to 1 minus cosine 2x dx. And here we can separate it to 2 parts. The first, that is 1 by 2. The first, that is dx, right? The integrand here, that is 1. And minus cosine 2x dx here, right? So the first, that equals to 1 by 2 here, that is x, right? And the second, this part, here you can use the substitution rule here. You can let u be 2x. We have solved this question, right, before. And here u be 2x and du equals to d2x. So that is 2 times dx. That means dx equals to 1 by 2 du. So we know that if I mark it 1 here, that is the formula 1, the integrand 1 here, that equals cosine u times dx. That means 1 by 2 du, right? And 1 by 2 can be taken out. That is cosine u du. Then we can use the formula directly. So that equals 1 by 2 sine u and plus c here. Then the last step, we substitute u back. So that is 1 by 2, and then sine 2x plus c here, right? This is the first way that we use the substitution rule step by step. You can calculate the integral separately, and then we write the result here. And here, if you are very familiar with the substitution rule here, you can also use the way directly. Here we found that is cosine 2x here, right? So if I want to use the rule, then the things after d should also be 2x, right? Should also be 2x. And d2x means 2dx. And to make them equivalent, here should be 1 by 2 here. Then we know these two parts are equivalent here and here. They are equivalent. And then we can get the result directly. That is equals 1 by 2x, and we times 1 by 2 separately, and that is 1 by 2x minus here 1 by 2 times 1 by 2, right? So that is 1 by 4. And here the integrand, that is cosine 2x. Here is d2x. So we can use the formula directly, that is sine 2x here. And the last step, don't forget to plus c here. So
Laoshi, how
okay,
can we get half here?
half here. Okay. Here because if we want to use the formula we can remember that is cosine x dx, right? So these two parts should be the same. Then we can use the formula. So if here is 2x, we have 2x here, then we can use the formula. But here we know that d2x does not equal to dx, right? d2x equals 2x prime dx, right? So equals 2 dx. So we know if we want to make the first this integral equals to this integral, here we should remove 2. Then we have to times 1 by 2 here. That is why, that is why we have 1 by 2 here.
Got it. Thank you.
Yeah, they are the same. Actually, they are the same. But I calculate directly without writing the substitution rule here. If you are not very confident to calculate it directly by this way, then you can write here step by step. That are also okay. Okay, any other questions here?
No, Laoshi.
Okay, good. And then the fourth one here. The fourth one, that is sine x power 3 here, dx. Sine x power 3 dx. So here, we should first rewrite the integrand sine x power 3 here. And we separate it to two parts. The first, that is sine x squared. The second part, that is sine x dx. Any student know that why I have to separate it to two parts? The first, that is power 2 times the power 1. Anyone knows? Okay, because here, sine x dx, if you are very familiar with the formula, you should know that d cosine x equals what? Equals cosine x prime dx, right? So that is minus sine x dx, right? And sine x squared equals 1 minus cosine x squared, right? So here I have changed the original integral. At first, the variable, that is x here, right? But I have changed the variable to cosine x here. So here, that is why I change it. So here, that can be written as 1 minus cosine x squared sine x dx. Then we can use the substitution rule here. So here, you can let u be cosine x. And then we know du equals d cosine x here. So that equals this one, right? Minus sine x dx here. So the original integral can be changed to here 1 minus cosine x squared, that is 1 minus u squared, right? And then times here sine x dx. Sine x dx should be minus du, right? So here we times minus du. And we use the sign minus to change the places of 1 and u squared. So that equals u squared minus 1 du here. So that can be separate to u squared du minus 1 du, right? And here we can use the formula directly because the first we can use the power formula, right? So that equals to 1 by 2 plus 1. So that is 1 by 3 and u power 3. Then minus u here. And the last step plus c. Then we substitute u back. U equals cosine x, right? So that equals to 1 by 3 cosine x power 3. Okay, here, 3 should be right here, not after x. Because we have talked about cosine x power 3 means 3 cosine x to be produced. And cosine x power 3 means the function inside cosine, that is x power 3. They are totally different. They are totally different. So here you should write the power 3 here. And then minus cosine x. And then plus c here. So here is the solution for the question number 4. Any questions here? Any questions here? Okay, no. Okay, so now we come to the last one, number 5. Okay, so here the integral that is tangent x, right? So first we don't have a formula that the integral is tangent x. You should know that. And second, tangent x can be written as sine x by cosine x dx, right? And here again, sine x dx, actually that equals d cosine x. Don't forget the sign minus here, right? Here we have calculate above, right? Here. So if you know that, we can also let u be cosine x. So du equals to d cosine x, that equals to minus sine x dx. So sine x dx equals to minus du here. Then the integral can be written as here sine x dx, that is minus du. So minus du by cosine x, that is u here, by u. So that means minus 1 by u du. Then we can use the formula that equals to minus ln absolute value of u, then plus c. So the final result should be minus ln absolute value of cosine x plus c here. So this is the result for number 5. Any questions here? No questions?
No, 老师。
Okay, so that means if if I gave you guys this kind of questions in the final paper, then you can work it out, right? Because you don't have any questions here, right?
Yeah, Laoshi.
Okay. Okay. So I know the level, how you learn. Okay. So here are the questions about substitution rules. And I think if you want to solve these kind of questions well, firstly, you should be very familiar to the formulas we have listed before, right? And the second, you should figure out how to use the substitution rule. That means you should figure out how to let a new variable, right, to make the integrand easier, that we can use the formula. Okay, so here are 2 kinds of substitution rules here, and you have to practice more and to speed up the calculation. Okay, so here are the solution for the homework. And then today we are going to learn another skill for calculating the indefinite integrals. And it is also very important, and we often use this skill. For example, first, if we want to calculate the indefinite integral as the integrand that is ln x. Here, actually, we don't know how to solve it because first, we cannot use the substitution rule, right? If you let u be ln x, for example, maybe some students think that we can let u be ln x, right? Then we know du equals d ln x, and that equals ln x prime dx, that equals 1 by x dx, right? But the integrand here, we don't have 1 by x actually, right? So we cannot remove 1 by x. Then we cannot use the substitution rule, then use the formula. So we know this way does not work here. So here, there is another way we always use, and the way we call it integration by parts. And this skill in our book, Thomas Calculus, that is in chapter 8. So if you want to search in the book, you can check chapter 8 here. And how to use this skill? First, actually, this skill comes from the product rule for calculating derivatives. So here, if u and v are 2 functions of x, then we have learned u times v prime equals, can you remember that? U times v prime equals to u prime v plus
Plus
u v prime here, right? U times v prime equals u prime v plus u v prime here. And then we can consider integration on both parts. So that means we consider integration on both parts, because here the variable that is x, right? They are functions of x. So that equals to u prime v dx plus u v prime dx here. And we consider part by part. On the left, here you should know that f prime x dx. Do you know the integral f prime x dx equals to what? So don't forget the indefinite integral. Actually, that means to find all the antiderivatives, right? And so here, f prime x, the one antiderivative, that is fx, right? So here that equals fx plus c here. Fx plus c here. For example, 2x dx, that equals to x squared plus c, right? And actually 2x, that is x squared prime here, right? So we should know that the left part equals uv, right? We don't write plus c here because we have integral sign on the right. So we don't have to write plus c here. This is the result of the left part. And the right part here, the first, I will write as v times u prime dx, and then plus u times v prime dx here. And remember that u is a function of x. So u prime dx, anyone knows u prime dx means, that means du, right? That means du here. Because when we calculate dy, that equals y prime dx, right? Here, the function, we use u here. So that is du. U prime dx means du here. And then plus this part means dv here, right? dv here. Then we have got the formula for integration by parts. That is uv equals, we first write this part, u dv plus v du. And here is another way to write it. We left u dv, we put u dv on the left. So that equals to u times v minus v du here. So the formula here, that is the formula for integration by parts. And integration by parts is a very useful scale to calculating indefinite integral and definite integral. So here we have the formula here. So we can look back to the example here. That is ln x dx. So you can compare this integral and the formula integral to make sure which part is U and which part is V. So here we can see U should be ln x, right? U dv, so U should be ln x. And V should be x here, right? So V equals x here. V equals x here. So we can use the formula directly. The formula says that equals U times V, right? Here U is ln x and V is x. So that is ln x times x here. Ln x times x here. And then minus. From the formula, we just exchange the places of uv here, right? So we exchange it, that here should be v, so that should be x. And after d should be u, and u here should be ln x here, ln x. So here we use the formula to rewrite this integral. So any questions for this step? Any questions here? No? No questions here? Okay, so we just use it. First, we choose U be ln x and V be x. Then we can directly use it to be ln x times x minus, we change the places of U and V here. So we have here, okay, here, maybe I can use the red color here to means U, Okay, and so here, to make it clear, I write U. I write x above ln x here, before ln x. So that is the first part. We don't have to calculate again. That is x times ln x. Then minus here. Here, first that is x. And then times here, d ln x. D ln x, we should know that equals ln x prime dx, right? And ln x equals 1 by x dx here. So d ln x equals to 1 by x dx here. So we know here should be 1 by x dx here. And you will find that x times 1 by x, so x can be cancelled here, right? So that equals x times ln x. We don't change it, just write it again. And then minus here, x can be cancelled. So the integral here, that is 1 dx. So the final result should be x times ln x minus here x, then plus c here. So here is the solution. The first example for using the formulas for integration by parts. So any questions, any doubt, you can ask me now. Do you have any questions? Okay.
Laoshi, can you please repeat?
What?
Can you please repeat?
So you means? Sorry.
I mean,
Laoshi,
can you repeat?
means repeat, please.
Repeat it.
Yeah.
From which part? Okay,
From this part.
Okay, this part. So first I want to know your dot. you don't know how to choose UV, or you don't know how to use the formula?
I'm doubt about the formula, how to use the formula.
Okay, how to use the formula. So here, if you have decided which part is U and which part is V, then for this formula here, the formula here, we have decided U be ln x, right? And V be x, right? So from the formula, the first, that is U times V. So the first part, that is ln x times x. I think you can understand it, right? And the second part, from the formula, this part, you just exchange the places of U and V. Here, on the left, ln x dx, right? We just change these two parts. This part, we exchanges the place here. So when we change the places here, that is x d ln x. Can you understand this step?
Yes, yes.
Yeah, we just changes the places of these two functions. And then we calculate this indefinite integral, right? And this indefinite integral, we should first make it clear d ln x. So here we solve d ln x. And d ln x equals ln x prime dx. And we use the formula ln x prime equals 1 by x, right? So that equals 1 by x dx. So we know d ln x equals 1 by x dx. So this part, d ln x, can be replaced by 1 by x dx. So here, that is 1 by x dx, and x, we don't change it. So we will figure out that x times 1 by x equals 1 here, right? So we can simplify it to 1 dx, and then equals x here. We plus c at last. Can you understand this time?
Yes, yes. Yes,
Yeah.
yes, Laoshi.
Okay, okay. And other questions about it? Anyone have other questions? No, no questions? No questions here? Okay. Okay, and this is the first example. And for this example, I write it again here. For this example, actually it is very easy for us to choose which is U and which is V, right? Because we only have one function as the integrand. So that is definitely U here. Okay, I will write the formula again here for U. U dv equals U times V minus V du. So for this example, we can decide directly that this part ln U is U and this part X is V as the formula here, right? Because we only have ln X here. But if I give you another example, maybe you should think about it that here, if I have changed the integrand as x ln x dx. So here, guys, you will find that here the question is more completed because we have two functions here, x and ln x. Then from the formula, u should be one single function that cannot be composed by two functions. So we should decide, we should think about one thing, that how to choose, how to select one function to be the function u, and the other, obviously, that is v, right? So here, we have to know the, I will write here, the selecting principle for u. If we can make the decision which function is u, then the other is v, right? We only have two functions here, u and v. So here we only gave the selecting principle for u. That should be, we should follow the order as follows here. The order that is, the first that is inverse function. Inverse function. Inverse trig function. Inverse trig function means, for example, arc. We have seen that arc sine x, or arc tangent x, arc cosine x, right here. So the first, that is inverse trig function. That the second should be log functions. Log functions, and the log functions we use most, and that is ln x, right? Ln x is a special kind of log functions with the base e, right? And number three, that is power function. Power function means maybe x power 3, x power 7, and so on. And here, a special one here, that is x power 1. X power 1, or we just write x here, right? Don't forget it. It is also a power function where the power is 1, right? And here, number 4, that is x per function. X per function means we usually use, that is e power x. E power x. And the last one, that is trig function. For example, sine x, cosine x, tangent x, secant x, and so on. And here, you should remember, you should know that here I will write with red color, means it is very important. That means the former has the priority. That means if you found two functions here, for example, the first, that is x, the second, that is ln x, right? And here x means power function, and ln x means log function, right? The former had the priority, means ln function had the priority. That means ln x should be u here. Should be u here. So we let u be ln x. Can you understand, guys? What
Yes,
I mean? Okay. Okay, so here, that is why we choose ln x be u. Then here is another question. We choose u be ln x. That means which is v? V equals to what? Equals to x? Equals to x? No, actually no. You should rewrite the integral here as this type. That is u dv type. U dv type. So here, if we let u be ln x, you should write it as only u as the integrand here. So we only have ln x here. Then the function after d, that is v. So here for this example, you should know what is v. That means how we can rewrite this integral to make they are equivalent and to make only ln x left here. That means we should know here ln x can be left here. We have x dx here, right? So you should know that x dx equals d what here? D what here? So guys, can you fill in the blank? X dx equals d what?
1.
1 Laushi, 1.
1? Really? 1? 1 here? 1 here? Guys, d, if you think it is a constant, 1, that equals, don't forget it, dy equals y prime dx, right? So d1 equals 1 prime dx, and 1 prime equals 0. So 0 dx equals 0, not x to x. Not x to x. So how to find it? Here,
X plus 1.
x plus 1. X plus 1. You can check again here. Okay, here. Let's check again here. X plus 1 here.
Laushi, 1 divided 2 x square.
1, what? 1?
1 by 2
1 by 2
x
times
square.
Times x squared, right? That is correct. But here, we will check again here. If we think that is x plus 1 here, x plus 1 here, so that should be x plus 1 prime dx, right? So that should be 1 times dx. So that is dx, obviously not x dx, right? So we know that is also not correct here, not correct here. So how to find the things inside after d here? Actually, that means you find one antiderivative of x here. Find the hint here, that is to find one antiderivative of the function. Here the function is x here. So we just find one antiderivative of x. So we know which prime equals x. That should be, actually we can use the formula. Here the power is 1, right? So that's, yeah, 1 by 1 plus 1, x power 1 plus 1, right?
Yeah.
Yeah, so that should be 1 by 2 x squared. Yeah, so here we can use the formula. We can use the formula to get what is the function after d. So here the function should be x squared by 2, x squared by 2. So here that is x squared by 2. That means v equals x squared by 2. V equals here, that is x squared by 2 here. Okay, so now we make it clear which is u and which is v, right? And then we can use the formula. And I will write the formula again to make you see it clearly, and you'd better remember it now so we can use it. That is u dv equals uv minus v du here, right? So here we have known that u equals ln x and v equals x squared by 2, right? So the first step, that is u times v. So we just times ln x times x squared by 2. And then minus, we exchanges the places of u and v. So here should be x squared by 2 d ln x. The first step at the beginning of learning integration by parts, you'd better write step by step. So the first step, you just exchange it. So here we know that equals, to make it clear, I write x squared by 2 before ln x. So that is x squared by 2 times ln x minus here x squared by 2. Now we can calculate d ln x. Remember that d ln x equals ln x prime dx. That equals 1 by x dx, right? So here we have 1 by x dx here. So we can see x can be cancelled. And here the constant 1 by 2 can be taken out. So that equals to x squared by 2 ln x minus here 1 by 2 x dx, right? So we can use the formula directly. That equals to x squared by 2 times ln x minus 1 by 2. Here we use the formula. That is 1 by 2 x squared, right? And then plus c. And we put these two constants together. That equals x squared by 2 ln x minus 1 by 4 x squared plus c here. Okay, I will make it smaller to let you see the whole procedure. And any questions here? Any questions here? Do you know? Any doubt about the steps? No, no questions? Okay, good. Maybe I think that means you can understand the way, the method integration by parts well. And I think that is very useful. That is a very good way to solve it. Okay, so now I will give you another example here. You have to practice about the integration by parts by yourself now, this time. And show me the procedure in the WeChat group here. So maybe here is the second example. The second that is, please calculate x times cosine x dx here. And I think you have the notes, right? So you can see the selecting principle on your notes. Or you don't have, if you don't have the notes, please take a picture here about the selecting principle for you and the formula for integration by parts. And then you can solve this question. Now, I will give you maybe 3 to 5 minutes. And if you have any doubt, you can ask now. I'm really happy to see that you know how to use the formulas for integration by parts, and you can finish the question so fast. So that is a happy news for me. So here we will solve it together. Okay, here we will solve it together. The first thing we should know that which part is U and which part is V, right? And from the selecting principle of U, that means here we can see X is power function and cosine X, that is trig function, right? And we know power function, the order of power function, that is number 3, and the order of trig function, that is number 5, right? So we should choose X. We should choose X as the U in the formula, right? So first, we have decided that X be U, X be U. Here, U be X. And which is V, that is a question. So here, U be X means from the formula here that we should change the integral as only U at the integrand, and all of the other parts should be behind D, right? So we know U can be left here, and the cosine X dx should be changed to the type dv, right? So here we should consider that cosine X dx equals d what here. And we can use the formula, right? Or if you are very familiar with the rules for calculating derivative, we should know that is d sine x here, right? D sine x equals cosine x dx here. Here we just choose one antiderivative. That is okay. That is enough to use the formulas for integration by parts. Because actually d sine x plus c equals cosine x dx, right? We have discussed about it. So here we just choose one here. That is enough. So here we know V should be, that means V should be sine x here. So we can rewrite it as x d sine x. So here we can use the formula here. That should be U times V, right? U times V. So that is x times sine x. So we have x here. We have x here. Don't miss it. And then minus, we change the places of U and V. So here integrand should be sine x. And here we just change it places. So sine x dx here. And we know that equals x sine x the same. And then minus here. Sine x dx equals what? Equals minus cosine x, right? Equals minus cosine x. And then plus c. So we have the final answer that should be x sine x plus cosine x plus c here. So here is the solution for number 3, the question number 3. So any questions about this one, this example?
X stands for U, right, Laoshi?
Yeah, X stands for U.
Okay.
Any other doubt? No. Okay. Okay. So now we will take a 15 minutes break, and please be back after 15 minutes. So that should be 32, right? 3:32 p.m. Okay. Let's take a break, guys.
Okay, 老师。
Okay.
Okay, 老师。
Okay, guys. Here are 3 extra exercises here. Also use the method integration by parts. So first solve the 3-1. Pay attention to question number 5. By now, I didn't see a student who did the question totally correct. Maybe some students get the correct answer, but the procedure is not correct. And some students, the procedure is almost correct, but they didn't get the correct final result. So pay attention to question number 5 to think about it again. Okay, now let's solve these 3 questions together. First, let's solve number 4. Okay, and number 4 here, x, e, x, dx. And most of you knows that we should choose here u, b, x, right? u, b, x. And we found ex, dx equals dex, right? So we choose vbex. So here we can change it as the form that is x dex. Then we use the formula that equals to u times v. That means x times ex. And then minus, we exchange the places of x and ex. So that is x dx here. And indefinite integral ex dx, that equals ex plus c, right? So we have the final result, that is x ex minus ex plus c. Or you can write as ex x minus 1 plus c. Each one is okay. Each one is okay. You don't have to take the function ex out as a common factor. You can just leave here. Okay, so here is the solution for number 4, and I think that is easy for you, right? And now we will solve number 6. Number 6. And number 6 here, that is ln x squared dx here. And there is one simple thing here, that is you don't have to be confused about which is u and which is v, right? Because the integrand here, that is only one function, ln x squared. So that should be u here, okay? So u be ln x squared. And apparently here v be x here. So that equals u times v. And to make it clear, we often write x before ln x squared. Ln x squared. So that is x times ln x squared. And then minus, here we change the places of x and ln x squared here. And here you should know that the ln x squared equals ln x squared prime dx, right? And here, ln x squared, it is a composite function, right? Here we should use the chain rule to calculate from the outside to inside. Remember that the outside, the outside function, that is the power 2 function, right? And the inside function, that is ln x. Remember that? So here we have to calculate from outside to inside. So for the outside, that is 2 ln x, and times inside, that is ln x prime, so times 1 by x here. So we have that is, we can write it as the integrand inside here. That is x times ln x squared minus here x times, we use this part, 2 ln x times 1 by x dx. Okay, guys, about this part, ln x squared prime, do you have any questions here? Do you know how we get this one, this part?
Sir, could you please repeat again?
Okay. So here, the question is how to calculate ln x squared prime, right? That means here we want to calculate d ln x squared by dx. So here we use the way we call it substitution rule also, as we calculate the derivative. So here, that is dy by dx equals dy by du times du by dx. Remember that? And here, u should be ln x. So y equals u squared here, right? So here we know dy by dx equals First, dy by du. Here, dy by du means 2u, right? And times du by dx here means 1 by x. And then we substitute u back here. U equals ln x. So that means 2 ln x times 1 by x. Can you understand? Here?
Yes, 老师.
Okay, that is a chain rule we have learned before. Okay, so here we can continue here. We found that x can be cancelled here, right? So we have that is x times ln x squared minus here we can take the constant 2 out. So that is 2 times ln x dx here. Remember that this is the first example before we learn the integration by parts, right? So here we have to use integration by parts again here. So we should know that ln x dx. So I will skip some steps here. I think you can understand. So here, for this indefinite integral, ln x means u and x means v, right? So that equals x ln x minus, we exchange the places of x and ln x. So that equals x ln x minus x times 1 by x dx, and x can be cancelled. So that equals x ln x minus x plus c here, right? So we know the original indefinite integral should be x times ln x squared. Here, don't forget the constant 2 here. So minus 2x ln x minus x here and plus c, right? So we can get that is x ln x squared minus 2x ln x here. 2x ln x here and plus 2x and plus c here. So here is the whole solution for question number 6. Any questions here, guys? Do you have any question? No? Okay, good. So we come to question number 5. There is some trap here. So you should be careful when calculating. And that is x e power minus x dx here. So here, as the selecting principle, we know we should select x as u, right? So u should be x, but here is the question that which is v. So here we should know e minus x dx equals d what, right? So here you should remember one thing, that as we know here, ex dx, we all know that equals d ex, right? Here we can change the letter. As long as these two parts are the same, then it follows this equation. So eu du also equals d eu, right? They are the same. So here we pay attention to the part on the left. That is e minus x dx, right? Here, minus x here. So if the function after d, that is also minus x, then we can use it directly. we can think that u be minus x, right? So here, e minus x, d minus x should be equal to d e minus x here, right? And then we compare these two parts on the left. The original part, that is e minus x dx, e minus x dx, right? And the formula, if we want to use, that should be d minus x. So we should know that d minus x, that equals minus x prime dx. So should be minus dx, right? So that is minus e minus x dx here. So we know that e minus x dx should be equal to minus d e power minus x. Can you follow this step here, guys? Can you understand why we have minus here before d? Can you understand? Or any questions here? Any questions here?
No, 老师。
Okay, so here we know that should be minus dEx. Now we can change the original integral to the formula type, right? So here should be x, we left it. And then d e minus x, and we can take the sign minus here outside the integral sign. So here we can use the formula that is here. Don't forget this sign, okay? And the formula that is applied for this part without the minus sign here. So here that is u v. So that equals u times v, means x times e power minus x. And the minus here, we change the places of e power minus x dx here, right? So here we know that equals minus xe power minus x, and here plus e minus x dx here. And then that equals for this part, actually we use this again, or we use this formula again. So here I want to change this part and this part to let these two parts the same. So here, that is minus x e minus x plus, then here e minus x, we cannot change it because minus here is as the power. We cannot take minus out of the function, the expert function. So minus x here cannot be changed. So we just can change here. We can change here. That is d minus x, d minus x. And then if we want to change it to d minus x to make these two parts equivalent, these two parts equivalent, we have to make up minus here, right? Because minus makes positive, right? So here we have changed it to this type, and that equals minus xe power minus x, and then minus right here, that is minus, and we can use the formula that is e minus x, and then don't forget to plus c here. So here is the solution for number 5. Solutions for number 5. Any questions? No questions. Okay. So pay attention to the sign. Pay attention to the sign. Don't make little mistakes here. Okay. And we will practice the last question for integration by parts. And the question that is this one. Ex sine x dx. And here I want to say one thing, that from the selecting property principle, we know that number 5, that is x per function, right? Number 4, that is x per function, and number 5, that is trig function. And when we solve the questions, number 4 and number 5, they can be exchanged. You can choose sine x as u, or you can choose ex as u. Which one is okay? Mostly, they can be exchanged. The places of number 4 and number 5 can be exchanged. So I will mark here. You can choose as you like. These two. They can be exchanged. They can be exchanged. Okay. So here, please solve question number 6. I will give you maybe 3 to 5 minutes to solve it. And then we will learn the next part. Okay, guys, let's solve this question together. And in the WeChat group, I have marked one answer that is totally correct. And I will use another way to solve it. So here, most of you choose U, B sin X, U, B, E, X, right? And here, as I just saying that here you choose U, B sin X or U, B, E, X, both are okay, both are okay. So here, because I was thinking that D sin X, D cosine X, maybe there will appear the minus sign here, right? So I choose EXBV and sin XBU here. So I will rewrite it as sin X DEX. But if you choose sin X BV, no, UBEX, that will be okay, that will be okay. So here, I will change it to sin X DEX here. And we know it is U and it is V here, right? So we use the integration by parts. That means U times V. So EX times sin X, right? And minus here, we change the places of U and V. So here that is D sin X here. And that equals EX sin X minus EX cosine X dx, right? And here you should remember one thing, that if at first you choose sin X be U, EX be V, then at this step, you should also choose EXBV. That means you should also take this part after D, So here, that equals EX sin X minus cosine X DEX here. So you should remember this important step, that you should make the same choice here. So that equals EX sine X minus EX cosine X minus, we change the places of these two. That is EXD cosine X here, right? And then that equals to EX sine X here minus EX cosine X here plus, right? Minus makes plus here EX d cosine X means minus sine X dx, right? And we can take the minus sign here outside the integral sign. So that equals EX sine X minus EX cosine X minus EX sine X dx. Okay, and don't forget the left part. What is the left part here? The left part here, that is, I will write here, EX sine X dx, right? So for this step, you will figure out one thing, that is the left part, EX sine X dx, right? And the right part, EX sine X dx, right? So we can put this part from right to left. That means 2 times EX sine X dx equals EX sine X minus EX cosine X plus C, right? So we finally find that EX sine X dx equals, we take 2 from left to right. That means 1/2 EX sine X minus EX cosine X plus C here. C, you don't have to write C/2 because C here means any constant. So it can be 1, it can be 2, it can be any constant. So C/2 also, that is also a constant, right? So we can use C here. Or if you want to make it clear, you can write C1 here, C1 here, and then you can write plus C here. So here is the final result for this question. Okay, any question, any doubt about this example?
So could you please repeat from
Which part?
from this part?
Okay, from this part. Which part? The third line?
Yeah.
Okay. Okay, here. From this part, from this line. For here, first we use the integration by parts to get this one, right? And then we found here is another indefinite integral, and that is the form of this indefinite integral that is very similar to the original one, right? So we think we can use integration by parts again. So here, EX cosine X dx, right? And we should follow one principle, that is, I have emphasized before, if you choose EX here as V, then for this part, you should also choose EX as V. That means we should write it as cosine X dEX here, right? Because dEX equals ex dx. They are the same, right? So it is a very important thing you should remember. And here, if you don't write, you write here, I want to leave ex here as u, and sine x, you should write it as what? Cosine x here. Don't forget the minus sign here, right? If you start to solve this question as this way, for here, you should choose ex as u as well. So you should follow the same choice, same principle here. So maybe later I will solve it again by choose ex as u to show you again. So here, because at first I choose ex as v here, so now here I should also choose ex as v here. And then we use the integration by parts again. That means cosine x times ex minus, we change the places here, ex d cosine x, right? And this part the same, ex cosine x minus here d cosine x, here d cosine x equals cosine x prime dx, that equals minus sine x dx here, right? So here minus means plus, so that is ex sine x dx. So we come to this step. We just use integration by parts again for this integral. Can you understand now?
Yes, 老师. Thank you.
Welcome. And now we can solve it as another way. Like most students did just now, that we can choose the question that is ex dx, right? Sine x dx here. And most students choose ex as u, okay? So ex be u. Then sine x dx, then we should write as cosine x. D cosine x means minus sine x dx. So here, don't forget the sign minus here. So that equals here ex d cosine x here and minus here, right? So that equals minus ex times cosine x. We use integration by parts, the formula, right? And minus, we change the places, cosine x dx, right? And that equals here, minus ex cosine x. Here, minus means plus here. So plus cosine x dex means ex dx here, right? And here you should remember one thing. At first, you choose u as ex here, u as ex here. So for this step, you should also choose ex as u here. So here that equals minus ex cosine x plus, we leave ex as the integrand as u, and then cosine x dx makes d sine x, right? And that equals here, that equals minus ex cosine x, the same. And then plus we use integration by parts. So that should be ex sine x minus, we change the places here, sine x dx here, right? And this part, that is minus sine x ex dx. And you will also figure out that the original, that is ex sine x dx. And here we also find ex sine x dx, right? And we let it be I, the letter I. So we have 2i, double I here, equals, here we make the positive before the negative. So that is ex sine x minus ex cosine x plus c, right? And then you will find I equals 1/2. You can take ex out, sine x minus cosine x, and then plus c here. And you will find they have the same result, right? The same result here. So here are two ways to solve it. Any way is okay. You can choose the trig function or the expert function as you. Which one is okay? Any questions about it? No questions, right? Okay, so for now, we have learned two skills to solve indefinite integrals. The first, that is substitution rule, right? And the second, that is integration by parts. Of course, if you can use the formulas directly, that is the best thing for us, right? That is really easy. So here you should remember the skills to solve indefinite integral, because for now, we will learn a new chapter, that is definite integral. And how to solve definite integral, the skills, we still use the skills that solve indefinite integrals. That means substitution rules, formulas, and integration by parts. So this chapter in our book, that is chapter 5. Here, we will learn integration, or we will learn definite integral here. And the first, we should know how the definite integral comes from. That comes from a geometric matter. So here, and please remove the blue circle. Thank you. And here, if we want to calculate the area of a region, for example, the region that is here, with the length, maybe the length that is 1, and the width that is half. And here is the region, maybe we can call it region 1. If we want to calculate the area of region 1, we know we have the formula, right? That means 1 times 1/2 equals 1/2, right? And if we want to calculate, for example here, a circle with the radius 2. So here should be 2, right? And here should be -2. And the region, that is the center, right? So here we know if we want to calculate this region, we call it region 2 here. that the area of region 2, that should be, we can use the formula again, that equals pi times 2 squared, right? So equals 4 pi. But now, if I want you guys to calculate the area of this region, and the region that is here, 1, and this curve, the function of this curve, that is y equals x squared here. Here is the region 3. Here, I want you guys to calculate the area of region 3 that lies above the x-axis below the curve y equals x squared, and between the vertical x equals 0 and x equals 1, right? Here, I want you guys to calculate the area of this region. I think it is not easy, right? Because we don't have a formula. We cannot use the formula to calculate directly. So here, the definite integral emerged. So that means the first thing you should know the geometric meaning the geometric meaning of the definite integral is the area of the region. And we don't have a formula, right? Of course, if we have a formula, we can use the formula directly. So here we know why we have definite integrals. And here, how to calculate it? First, I will give you the thought here. First, we can subdivide the interval from 0 to 1 to many parts, maybe n parts. And then here we can see we have subdivide the region into many small parts, right? And then we can estimate small parts, the area of the small parts. And then we can calculate the summation of the small parts. And then we get the limit. So we can get the region of this part. And the 4 steps I have talked about. The first, that is partition. The second, that is estimation. And the third, that is summation. And the last, to get the limit. These four parts make here, make an expression here. We can get the area here. Then we use a symbol. And this symbol, that is, for this example, we can write like here from 0 to 1. Here, the first, that is the integral sign. And here, the lower, that is 0, and the upper, that is 1. And then we write the function here. So that is x squared here. And then we write dx. And we use this expression to express the area of this region. So that is definite integral. Why we call it definite integral? Because as above, we have learned in definite integral here, you will see, for example, here, we only have the integral sign, right? And we have to plus c here. That means the result of indefinite integral should be a huge of expressions, right? But here we have lower limit and upper limit here. To make it, you will get one single constant here. That means the area of this region. So the result of definite integral, that should be a constant. That should be a constant. And that is the area. Okay. So now we have the definite integral. And the general expression we usually write as from a to b. The integrand, that is fx, and then dx. And here a, we call it lower limit. B, we call it upper limit. So here we know that from a, b, actually in this question, that is 0 and 1. So here we should know a, b, that is a closed interval here. Closed interval here. So here you can call it a lower limit and upper limit here, and integrand fx here, dx here. So it is it is a definite integral for us. And the geometric meaning of definite integral, that is the area. If the function fx, that is above the graph, that is above the x-axis here. Because if it is below the x-axis here, I will draw here. If the function that is here, as you can see, that is below x-axis here. So the value of the definite integral, that means the negative value of the area of this region. Okay, so you should know what is a definite integral and the geometric meaning of definite integral. And now I will show you an example here. And the example that is, here we don't know how to calculate, right? But we can still calculate the definite integral. For example, here, I want you to find the value of this definite integral. So here you should think about the geometric meaning of the definite integral. Okay, so as we have talked about, lower limit, that is 1, and upper limit here is 2. So that means the interval, that is from 1 to 2, right? So we can draw the graph here. From 1, maybe here is 1, and here is 2. From 1 to 2. And then the integrand here, that is 3, right? So that means y equals to 3. That means the function is a constant function and always equals to 3. So maybe 1, 2, 3. Here is 3, right? So that is y equals 3. So this definite integral means the region here lower than y equals 3 and upper than the x-axis. So that means the area of this rectangle. So that equals 1 times 3 equals 3. And after next class, you will also use the formulas to calculate this integral, and you will find 8 is actually equals to 3 here. So here is the geometric meaning of definite integral, and I think that is a quick way for us to solve it. For another example here, another example that is from -2 to 2. Square root of 4 minus x squared dx. Can someone draw the geometric meaning of this definite integral? Think about it. You can draw on your paper and try to figure out the result, the value of this definite integral. Anyone who can draw the graph here? Last year when we learned about this course, the students tell me that they are not good at drawing the graph. So how about you guys? You feel drawing the graph is difficult or not?
Difficult.
Yes, Lauchi. Drawing graph is so
Okay.
difficult.
Also
I'm not that
difficult.
good about that.
Okay, so I know that. Okay, here, you can think about it in this way. So if I want to make it clear the geometric meaning of this definite integral, one important thing that is I should know this curve. What is this curve, right? So here you can think about it. You can let y equals square root of 4 minus x squared, right? And y equals square root, that means y should be larger or equal than 0. That is a condition. And then for this equation, we can calculate the square on both sides. So that equals y squared equals square root of 4 minus x squared outside square. So that equals 4 minus x squared. Don't forget y should be larger or equal than 0. And then we have y squared equals 4 minus x squared, right? So we have that is x squared plus y squared equals 4. Under the condition, y should be larger than 0. So guys, do you know the graph of x squared plus y squared equals 4? What is the graph? Do you know that?
Circle.
Circle.
Yeah, circle, and the center that is the origin, right? So here, that should be the circle here with the radius 2, and this is the circle. Maybe here is 2, right? But the condition that is y is larger or equal to 0, right? So that means we only have this half circle, this semicircle, right? And here, the point here, that is a -2. right? The radius that is 2. So here we know here it is y equals square root of 4 minus x squared. So that is the curve here. And so we look back to the definite integral here. That should be from -2 to 2. So you can see here -2, here 2. And below the curve is here. Above the x-axis is here. So I want you guys to calculate the region, the area of this region, and that is half of the circle, right? So that equals to 1/2 times pi 2 squared. So that equals 2 pi here. 2 pi here. Can you understand now? Or not, guys?
Yeah,
Please repeat, Lordship, please.
Okay, okay. So here is the way to calculate a definite integral by using its geometric meaning without calculating. So here is the definition of definite integral. And then we will learn the properties of the definite integral. And that is easy to understand. So the last part, that is the properties. Of definite integral. So here, you should remember 2 rules first. The first, that is, from A to B, fx dx equals here. If I change the places of lower and upper limit, that means that is from B to A here, and the same integrand, same dx here, then this equals minus here. So if I change the upper limit and lower limit here, you should remember to add minus sign before the integral. So it is the first rule. And the second, you should remember that if the lower limit and the upper limit, they are the same, that means from A to A, and that should be 0. Or you can think these 2 rules as regulations here. So here too, you should remember the other rules. And then we also have the sum rule and product rule here. That means from A to B, fx plus gx dx, that can be separated, equals from A to B, fx dx plus from A to B, gx dx. And also, if that is from A to B, k times fx dx. Here, k is a constant. Here, and that equals, we can take the constant out. So that equals k times from A to B, fx dx here. So the definite integral also follows the sum rule and product rule here. And there is another rule for it. Number 4, that is, if the interval can be subdivided to from A to C plus from C to B, then we will have that from A to B, fx dx, that equals from A to C, fx dx, plus from C to B, fx dx. And I think it is easy to understand because we have talked about the geometric meaning of the definite integral means the area of the region, right? So we back to this graph here. If this is the curve of y equals f of x, and this is the vertical x equals a, and this is the vertical x equals b, so the left part means the area of this region, right? And here we have a point between A and B. So maybe C is here, right? C is here. And we know the first definite integral from A to C. That means the area of this part, right? And another from C to B here, that means the area of this part, right? And obviously they are equivalent. So we can put a point, we can select a point between A and B, and to separate the definite integral into two parts. So here are 4 properties we often use when we calculate the definite integral. So next week, we will learn how to calculate definite integral because not every function we can draw the graph. And I know most of you are not good at drawing the graph, right? So we have to learn how to use the formulas, how to use the methods we have learned to calculate the definite integral. And that is the task we will learn next week. So any question about today's class, guys? No? No questions?
No,
Okay, so I will not leave the homework today, this week. But I think if you are not very familiar with the methods we have learned for calculating indefinite integral, maybe you'd better choose some exercise to practice. Okay, and if you don't know whether you did correct, you can send the procedure to me and I will check for you. Okay, guys? So next week, we will understand calculating definite integral better. Okay, guys?
Okay, Laoshi, thank you.
Okay.
Thank you.
Okay, so that is all for today's class. And if you didn't submit the homework last week, you have to submit the homework before 8 p.m. Beijing time. Okay, that is the deadline. So see you next week, guys.
谢谢老师，拜拜。
Okay, bye.
谢谢老师，拜拜。再见，老师。
再见，拜拜。